So let's do an example of what we learned about inverses and how to express them. So here's the example. So let's say let f of x equal 2x minus 5. The function f of x is reflected in the line y equals x to g of x, right? And the question says find g of x. All right? So how do we find this? So what's screaming out is this information over here. So the function f of x is reflected in the line y equals x. If anything is reflected across y equals x, and if anything is reflected across y equals x, that is equivalent to its inverse. So g of x is really just the inverse function of f of x. So we know that g of x is the inverse of f of x. You don't have to write that down, but I just wrote that down for your understanding. And so all we have to do is find the inverse of f of x. So if f of x is equal to 2x minus 5, that means y equals 2x minus 5. We have to find its inverse. So x equals 2y minus 5. And if I solve that, I get y is equal to x plus 5 divided by 2. And now, if I basically write this, I'm going to write this as f inverse of x is equal to x plus 5 divided by 2. But remember, I didn't ask you for f inverse, I asked you what g was. And we know that g of x is equal to f inverse of x. So basically what that means is that g of x is, since f inverse of x is equal to that, so g inverse of x, so g of x is also equal to that. So it's equal to x plus 5 divided by 2, and there you have it. So the key thing to remember is that when we say reflected in the line of y equals x, the function that we get after the reflection, so the image of that function, is actually the inverse function. So get the original function, find its inverse, and that's what the transform function will look like. I'll see you in the next video.